Hello, this is Steve Probst with 4C Conference. 4C stands for Connect, Collaborate, and Contribute to Compliance. Today, we'll be connecting and collaborating with Warren Merriman of Emerson, talking about solutions relative to tank water draws. Warren, would you share with us a little bit about your expertise and your role with Emerson?
Sure, Steve. It's a pleasure to be here. I appreciate the invitation. I've been with Emerson for 27 years, and my current role, I'm the Business Development Manager for Refining in the Measurement Solutions business unit of Emerson.
One of the things we talked about with regard to measurement and sensing is that measurement and sensing allows the reduction of emissions, improved safety, improved energy intensity index, improvement in greenhouse gas emissions, but it also saves money. Could you give us some examples of your technology relative to water draws, how it saves money, how it reduces emissions, improves safety, all of that suite of things?
Sure. I guess as saving money is concerned, there is an overall fence line mass balance that takes place in a refinery. And as they look at their taxation, for example, whenever they bring in raw material, if they're bringing in water and that raw material, they're getting taxed on it. So they want to watch that water whenever they do their measurements after it stratifies from the feedstock. That's one element of savings. As it relates to environmental, we're pulling off of a water underneath a hydrocarbon, and emulsions and stratifications make it rather difficult, and perhaps some opaque materials will also make it difficult to visually see when am I reaching the point of hydrocarbon after the completion of my water draw from the bottom of the tank. And then from a long-term viability of the tank, water causes corrosion in tanks. So you might have a reduction in the life of that tank as well, and you want to manage that as part of an economic benefit.
Traditionally, from a refinery or chemical plant, the operator comes out to the tank farm, does a water draw. They would have watched that water draw to see when it's no longer water and there's hydrocarbon there. Tell me how your product improves upon that from an operations perspective.
Well, I think you had a real good description of exactly how it happens in the field, and there's a couple of different ways, one of which is probably the most prevalent, what you described, whenever we don't have automation at the site. And frequently what I see in off-sites, like a tank farm, is a low investment quality there. It's difficult to get the ROI in a tank farm. So there's frequently not a lot of infrastructure in a tank farm, and being remote, infrastructure typically costs more money. So frequently I'll see where we'll have manual operations that are taking place in the tank. So physically an operator would walk up to a tank and they would hand turn a valve, and they'd be looking at an indication of level on the side of the tank, which is where the problem might arise. Our measures that we might look at are when we reduce the water, we're actually looking at the true hydrocarbon, but we also create an emission issue whenever we have hydrocarbon breakthrough in the water. So there's a multitude of different departments that can benefit from this measurement. Predominantly what you see whenever they put this in is they're able to really mitigate the risk of large amounts of hydrocarbon that are breakthrough. I've seen results where throughout their pull off of the water, they're able to get down to a 2 liter content of hydrocarbon, very, very low hydrocarbon, which of course reduces the VOCs in the effluent treater or in the sewer system where they're draining the water to.
That's exactly the kind of technology that we want to feature at the conference, and that feeds into the boards and the CEOs and the vice presidents' goals of reducing emissions, because all the hydrocarbon that ends up in the water on that tank water draw eventually either becomes a VOC as it evaporates on the way to the wastewater treatment plant, or it becomes CO2 when it is eaten by the bugs in the wastewater treatment plant. Yeah. So it all becomes VOC emissions or CO2 emissions. So we don't want that hydrocarbon in that water. So reducing that hydrocarbon reduces emissions. Of course, that's also a refined product, which would then have to be replaced with a different refined product, which increases greenhouse gas emissions. And those emissions also will contribute to the health and safety. If we reduce the amount of hydrocarbon in the water, we improve the health and safety of everyone in the plant, because those VOCs are not going up into the breathing space of the employees. In addition to the environmental health and safety benefits and the cost savings associated with the product, are there any tax savings or other reasons that you would be interested in this product?
Yeah, it is kind of interesting when you start looking at a cross-section of where the value shows up. And you have departments that are looking at yield accounting, for example, and they're trying to validate and reconcile their information. So if they're looking at trying to see how much of my feedstock, for example, because we might have a multitude of different types of tanks. Finished goods is one, then we have intermediate type product, and then we have raw material product. And you'll probably see as you went down the list that larger content of water would be at the earlier part of the product or process. So as we're looking at, let's say, all the way down to the crude tank, and we're bringing in that crude material, we think we're buying crude, we're paying tax on our feedstocks. But as we look at what the content is after time and we settle and stratify that water out of the bottom, we realize that we've paid for and been taxed for water. So we look at that water draw coming off, and we have to reconcile that data back to our accounting department, who's doing a fence line mass balance, which is part of the governing entity that looks at our metrics to do benchmarking. And they make requirements as to how much or how accurate we're making our measurements. And this is a component that might not be thought of in that regard. So a taxation thing, as well as looking at how we're doing in our overall yield accounting for our metrics that we're meeting in our benchmarking.
It's fantastic. No one wants to pay taxes on water.
No.
And all refineries want to have a higher Solomon index.
Well, that's true.
So this technology helps with both of those. Thank you, Warren, for your time today and sharing your knowledge and passion with the 4C community and the Emerson community.